Good day. Today we're going to discuss inverse functions. To start, let's start to define the inverse functions. The function f and g are inverses of each other if f composed of g of x is equal to x for all x in the domain of g and g composed of f of x is equal to x for all x in the domain of f. Now, let's start to illustrate what is being said in the definition. Okay, let us say the table below illustrated a function. Okay, so our domain, we have these elements in our range. Now, as we can see here, this table illustrates a one-to-one function. So we have negative x, negative 1 to negative 1 in our y, 0 to 1, 1 to 3, and 2 to 5. Now, try to observe what is being illustrated in the second table. So we have here the second table. This is our domain, and this is the range. As we can see here, okay, the domain in the second table is actually the range in our first table. And the range on the second table is actually the domain of the first table. So in other words, this function, the second table, is actually making the domain, okay, making the domain back to the range of the first table. Okay, so we could say that the second table shows the inverse of the first table. So in other words, if g is inverse of f, okay, then the domain of g is the range of f, and the range of g is the domain of f. So we could always say that the function g is the inverse of function f if the domain of g is the range of f and the range of g is the domain of f. Now, since given two one-to-one functions f of x and g of x, if the f composed of g of x is equal to x and g composed of f of x is equal to x, then we say that f of x and g of x are inverses of each other. More specifically, g of x is the inverse of f of x denoted by g of x is equal to f raised to negative 1 of x. Likewise, f of x is the inverse of g of x and denoted as f of x is equal to g raised to negative 1 of x. Now, we have to take note that this illustration, f raised to negative 1 of x, is not equal to 1 over f of x. So, in the previous discussions in your junior high school mathematics, okay, if the algebraic expression is being raised to negative 1, then that can be transformed into its reciprocal. Now, in this case, we cannot apply that concept since the given examples that we have today are actually functions, not merely an algebraic expression. So, if we have a function raised to negative 1, then that means inverse function, not the reciprocal. Okay, let's have an example. Show that f of x is equals x cubed minus 1 and g of x is equal to the cube root of the quantity x plus 1 are inverses functions of each other. Now, take note from the definition that f of g of x is equal to x and g of f of x is equal to 1. So in other words, we have to satisfy these rules, this law, okay, that if we are going to make a composition of f of g and g of x, then both compositions is equal to 1. Now, let's first try to satisfy this condition. Okay. Now, in other words, we are going to replace the x in our f of x by the g of x. So, we have f of g of x is equal to the cube quantity of the cube root x plus 1 minus 1. Now, since the whole cube root is being raised to 3, therefore, we could have the exponent of 1. So, we have x plus 1 minus 1. Now, if we have 1 minus 1, the answer is 0. What remains is x. In other words, the f composed of g of x is equal to x, which is the rule, the first rule, or the first condition that we have to satisfy. The second condition that we have to satisfy is this one. So, what we did here, the x of our g of x is being replaced by our f of x. So, I placed here the x cubed minus 1. I place it here in the parentheses to emphasize that this is the x of our g of x. Now, since we have x cubed minus 1 plus 1, we have to combine like terms. So you have negative 1 plus 1 is equal to 0. So what remains is we have the cube root of x cubed. Now, since the index and the exponent of the radicand is the same, then we could have equal to exponent 1. So, what remains is x. Since, okay, the resulting expression is equal to x, then we satisfy the second condition. Therefore, as we can see here, since the f of g of x is equal to x, and g of f of x is equal to x, both f of x and g of x above are inverses of each other. Okay, now, how we are going to determine the inverse of a certain one-to-one function? Now, we have here the steps finding the inverse of the one-to-one function. The first step that we have to do is to replace f of x with y. If we already replace f of x with y, then we can now trade the places of x and y. So we have just to replace x to y and y to x. The next step that we have to do is we have to solve for y. And then, if we already have the value of y, or the algebraic expression of y, then we could now replace y with f of negative 1 of x. So let's have as example, find the inverse of f of x equals 3x plus 7. Now the first step that we have to do is we have to replace f of x with y. So instead of writing f of x, we have to write y equals 3x plus 7. So the f of x is being replaced with y. The second step that we have to do is we have to trade x and y places. So instead of y equals 3x plus 7, we have the y is replaced by x, the x replaced by y. So this is it. So the x and the y. Now the next step that we have to do is we have to solve for y. Okay, so here we subtract both sides by 7. Okay, to make it 0. So 7 minus 7 is equal to 0. Then we have x minus 7 since we subtract both sides by 7. Now we have x minus 7 equals 3x. Next, we just divide both sides by 3. So what happens in the left side, we have x minus 7 all over 3 since we divide both sides by 3. Now, as we can see here, it's better that our y will be in the left side. Okay, so we just interchange their places. So we have y equals x minus 3 over x minus 7 equals 3. Now, for the last step, we just replace y with f raised to negative 1 of x. So we just replace this y with this one. And that's our final answer. Let's have another example. Let's say find the inverse of f of x is equal to 4 over 2 minus x. Now, first one, we have to replace f of x with y. So we have this one, y equals 4 over 2 minus x. And then we have to trade x and y places. So that's it. Okay, now we have to solve for y. Okay, so as we can see here, since the right side is being expressed as a proportion, then we can use the concept of cross multiplication. So the 2 minus y is being multiplied to x. Now, next step here is we divide both sides by x. So 2, since we have a factor here, a factor of 4, we have a factor of x, then here 4, we just divide both sides by x. Next, okay, we subtract both sides by 2. Okay, so subtract both sides by 2. Okay, so 2 minus 2 is equal to 0. So that's why in this portion, the 2 is gone. So we have minus 2 here. Now, since we want to have a positive y in the left side, then we have to multiply both sides by negative 1. So what happens is we have this one. Okay, so 4 over x multiplied by negative 1, that becomes negative, and negative times negative equals positive. So here, the negative y becomes positive. Okay, so to have a much better format, okay, so we have y equals 2 minus 4 over x. Okay, now, it's better that we have to place it in a single vinculum. So we have to multiply 2 by the LCD. Okay, the LCD is x. So we have x over x. And then since they have now the same denominator, then we copy the denominator and we have to subtract the numerator. So we have y equals 2x minus 4 all over x. And since this would be our final the final output of this step, then we can now replace y with f of negative 1 of x. So the y here, the y is being replaced by f of negative 1 of x. And that is our final answer. Now, let's try to compare the graph of the inverses. Now, from the first example that we have f of x is equal to 3x plus 7. And the inverse of f of x, let's say g of x, is equal to x minus 7 all over 3. Now, let's try to graph the f of x. So this is the graph of the f of x. Okay, so that would be the graph, the blue one. Now, let's try to graph the g of x. That's the graph of the g of x. Now, to have a clear comparison, what happens in our graphs, let's try to draw x equals y. Okay, as we can see here, if we are going to fold the graph, okay, in this broken line, x equals y, we can see that this portion will touch the blue one. And the blue one below the broken line will touch the green one above. So in other words, the graph of the inverses are actually symmetric in terms of x equals y. So let's have another graph. Let's say from, again, our previous example, we have f of x is equal to 4 all over 2 minus x. Okay, and then the inverse of that, let's say g of x, we have 2x minus 4 all over x. So first, let's try to graph the f of x. So we have this one, our f of x, the blue one, and our g of x, the green one. If we are going to draw a line x equals y, okay, as we can see here, if we are going to fold the graph along with our line x equals y, now this green graph in our below the x equals y is actually this one, if we are going to fold. Okay, and then the blue one below the x equals y is actually the green one in the above the x equals y. So in other words, when we are going to graph the inverses, okay, the function in its inverses, we could say that the graph are symmetric in along the x equals y. So that's it for today.